Hello, this is Ms. Parks. In this section, we are going to be talking about polynomial functions, what degree means, what type of degree, and what the leading coefficient is, which has a really important effect on what the polynomial looks like when it's graphed. So what we have is we have all of these right now that are here. Let me add one more. If it's degree 5, it's quintic, I believe. So the degree is based off the highest coefficient of the x value. So if you look over here, the highest exponent, not the first one, okay? So the highest, because they might not be written in order, but the highest exponent indicates the degree of the polynomial. So we've been dealing mostly with quadratics, which are x squared functions, okay? And that's what we've been doing up to this point. But there are more, obviously, that can go on and on and on and on. So we're going to talk about the degree. If it's a function, you can't have any division if it's you can't have negative exponents, and you can't have any a variable in the denominator for it to be a polynomial function. Okay, so here we go. There's a lot of stuff. Decides whether or not each is a function. So for this first one, yes, it is. Okay, that's the first answer. Second part, write it in standard form. So standard form means that the highest exponent is first all the way down to the lowest. So that's already taken care of. It's already in standard form. Number 3, or state the degree. So the degree is the highest coefficient, which is 3. Okay. Let me erase that. The type is the next one. So if it's degree 3, that means it's cubic. And the leading coefficient. So the leading coefficient is the number in front of the highest exponent. So in this case, the leading coefficient is -2. And again, we'll discuss later how that affects everything. For the second one, we have if it's a polynomial function, and the answer is no, and because we can't have no negative exponents. On the variables. Because this means 7 over x, and you can't have an x in the denominator. So this one's no. For the next one, we have yes, it is. It is not in standard form, so I'm going to go ahead and write it in standard form. So g of x is equal to the square root of 2, x to the 4th, minus 0.8, x to the 3rd, minus 12. It has a degree of 4, which means it's quartic, and it has a leading coefficient of radical 2. For D, it's no, you cannot have a variable as an exponent. So pause the video, do the next 4 problems, and then come check your answers. Okay, so for the first one, yes, it is. It's already in standard form, and so this is standard form. It's already in the order that it needs to be in. Has a degree of 5, which is quintic, and it has a leading coefficient of -4. Second one is no, and that's why we have a negative exponent. The next one is also no, because we have an exponent, that's a variable. The next one is yes. It's not in standard form, so standard form would be the square root of 3, x to the 4th, plus 1/2 x squared, plus 19. This has a degree of 4, because that's the highest exponent, and that's quartic. And it has a leading coefficient of radical 3. All right, we're not going to do those for right now. The next part is we're going to evaluate. So when it says evaluate, this means that you're going to plug in a number into the equation and see what the answer is. So the f of x, or the function, is this. So when x is equal to 3, we would write that f of 3. And then basically becomes, every x becomes a 3. Okay, you need to show your work, so you always need to do exponents before multiplication. So this would be 2 times 81 minus 8 times 9 plus 15 minus 7, which is 162 minus 72. And I'm just going to go ahead and combine these, plus 8, which is 98. So f of 3 is 98. That also means that if you plug in the number 3 for the x, the number 98 will come out on the y if you were graphing this. So at 398, there would be a point on the graph that lives on that function. Okay, you guys go ahead and try the second one, and then pause that video so that you can do it on your own before checking. All right, f of 4, negative 2 times 4 to the 4th plus 6 times 4 to the 3rd minus 3 times 4 plus 11, which is negative 2 times 190, not 196, excuse me, that's 256, plus 6 times 64 minus 12 plus 11, which is negative 512 plus 384 minus 1, if I combine those together, which is negative 129. It's easy to make mistakes on these. You just need to double check and try not to go too fast. And again, that point would be that as an ordered pair. Okay, end behavior of a function is also important when it involves graphing. There are so many different polynomials, but what they have in common is either the degree is going to be odd, so all the odd degree polynomials are going to behave in very similar manners, and all the even degrees, so talking about, you know, the highest exponent, what we just finished talking about. So if they have odd degrees, then they're going to be pointing in opposite directions. So I don't know if you want to kind of remember that odd, their end behavior is in opposite directions. So if this part is, if it's positive, it's kind of like a line. As one, it starts down and ends up. So anything that's positive always ends in quadrant 1. Up at the top, it's going up. And anything that's negative will end in quadrant 4. It'll end down here. So they go in opposite directions. Their arrows point in opposite directions, I should say. Okay, so opposite arrows. Okay, if it's positive, if the leading coefficient, so we're talking about the a value. It's like when we did quadratics and when we're doing parabolas. When a is positive, it's going to end going up. And when an a is negative, then it will end pointing downward. Now for the even ones, they're just like parabolas and the quadratics that we've been doing. They go in the same direction, okay? So arrows point in the same direction. So that means that if it's a is positive, then both arrows go up. And there could be, depending on what the polynomial is, what the degree is, how many terms it kind of has in the middle. And then if it's a is negative, then it will be pointing downward. And we call it a negative polynomial. Okay, now this f of x step, I'm going to explain what that means. I don't really like the way it's written here. We're going to write this a little bit backwards, and I'll explain what that means in a minute. Okay, so really all you need to know is the degree, if it's odd or even, and if it's positive or negative. So this is odd. Excuse me, the degree is even, and a is negative. That means that the arrows will be pointing in the same direction and they'll be pointing downward. Doesn't really matter how many turns we have in there or whatever. So this is what we start with. Okay, so you kind of have an idea. So when we write this, I would like you to always write as x goes to negative infinity, then f of x goes to, and then we're going to figure that out, and then as x goes to positive infinity, then f of x, and I'm going to do this in a different color so you can kind of see, actually I'm going to do both of them in a different color so I can show you what that means. So again, as x goes to negative infinity, f of x goes to something. And let me do, I don't know, blue. As x goes to positive infinity, f of x goes to. All right. And we're going to repeat this over and over again. So I'm going to copy this. And we're going to copy, paste, and paste one more time because we're going to do that down here also. All right. So you always start the same way. So what this means is as x goes to negative infinity, they're saying as x goes to the left, what does the graph do? So as x goes to the left, because that's where negative infinity is for x, the graph points down. So that means it's going to negative infinity as well because it's pointing downward. Now, for the second part, as x goes to positive infinity, which is here, okay, so as I go to the right, what happens to the graph? Well, the arrow also points down, so it's also going to negative infinity. And so then those are the answers. Well, this whole thing is the answer as describing the end behavior. But as you can see, for the rest of it, the beginning part's all the same. You really only have to worry about the last two pieces here, where the arrow's pointing. Okay, so in this case, both arrows are pointing downward. And because both arrows are pointing downward, and we always do the left and then the right, okay, so then they're both going to negative infinity. For the second one, see if you could do this ahead of me. And then you can see if that works out. I know that this is just kind of an introduction to everything. All right, so this is what we're dealing with. This is the highest exponent. You need to make sure you look at the highest exponent. It is odd and it is negative. So that means that it's going to be pointing downward at the end, but they point in opposite directions. Okay, so the negative means it's pointing downward at the right side, and the odd means that the arrows point in opposite directions. Okay, now, so to do this, as I go to the right, the arrows go up. So that means it's positive infinity. And as I go to the left, or excuse me, that was left. As I go to the right, then the arrow goes down. So that's negative infinity. So for the left one, it goes up, and for the right one, it goes down. Here, for the left one, it goes down, and for the right one, it also goes down. Okay, so when you're doing this one, left and right, go ahead and figure that out. For 4 and 5, those are practice problems of these kind. So go ahead and do those first, and then so basically go ahead and do 4, 5, and 6, and then come back and check your answers after you've paused this video. All right, so for this one, f of 4 is equal to negative 4 to the third, and the negative sign is not to the third power, only the 4 is to the third power. So then we have this, which is going to be negative 64 plus 48 plus 9. So f of 4 is equal to negative 7. For number 5, we have f of negative 2, which is 3 times negative 2 to the 5th minus, minus negative 2 to the 4th, and again it's minus x to the 4th, and then minus 6 times negative 2 plus 10. So that's 3 times negative 32 minus positive 16 plus 12 plus 10, which is negative 64 minus 16 plus 22 for these last two, which gives you negative 90. If you try to put that in your calculator and your parentheses aren't in the right places, you're going to mess up, especially in this middle section right here because it's minus that to the fourth, which, yes, that's a plus when it comes out of there, but it's plus and it's minus a positive. And then for this last one, we have an odd, which means the arrows are pointing in opposite directions. We have positive, which means it's pointing up at the end, which means pointing down at the beginning. So the left side is pointing down, the right side is pointing up. So when it's pointing down, that's negative infinity, and when it's pointing up, that's positive infinity. So for the next section, we're going to be graphing polynomials by plotting points. We normally won't do this in the future, just so you know. This is the only time we're going to do this, just so you can kind of see that if you ever do get stuck on graphing a polynomial, that you can always take some points and try to plug them in, and then try to get an idea of what's going on here. So what we do know is that the degree is odd, it's 3, and that the a value is negative, so that I know that this graph will be pointing downward in that fashion somehow. So what we're going to do is we're going to be plugging in all of these numbers into this equation or this function for the x values, okay? And then we're going to figure out the y. So for -2, this is going to be negative, and then I'm going to try to, and then it's going to be -2 to the third. And then plus -2 squared, which is 4, plus 3 times -2, which is -6, minus 3. And I'm going to the right only because I have a whole bunch of numbers to do, so I'm going to go this direction. So then now I have 8 plus 4 minus 9, which is 3. So that value goes here, and that's a 3. All right, for the next one, if I plug in a -1 here, so I have negative, and then -1 to the third goes here. So that's -1 plus, and then -1 squared, which is 1, plus 3 times -1, which is -3, and then minus 3 for the last part. Okay, so that's going to give you 1 plus 1 minus 6, which is -4. So the next one, if I plug in 0 for all the x's, I'm going to get 0 plus 0 plus 0 minus 3, which is -3. Let's see. For the next one, if I plug in 1, then I get -1 plus 1 plus 3 minus 3, which is 0. Okay, for 2, we will have -2 to the third, which is 8, plus 2 squared, which is 4, plus 3 times 2 minus 3. So that'll be -4 plus 3, which is -1. And so now we're going to plot all of these points in this graph. Okay, and it's going to give us a little bit of an idea where everything is. So we have -2, 3, the first point. Okay, here, -2, 3. So -2, 3, that point. Second point, we have -1, -4. That's the point. The next point, 0, -3. The next point, 1, 0. And the next point, 2, -1. So what I do know is it's odd. And a is negative, so it starts up here and it ends down here. So we have to hit those points, and it has to be curved. Okay, so we have to start somewhere up here and somewhere down there, and it's more like a roller coaster. Okay, and most of these will be skinny and tall, so I'm gonna kind of go here, and it doesn't go straight up. It has to always go slightly at an angle. Okay, and it has to hit all the points that we have. We don't know exactly where it hits everywhere, but it definitely, because it's to the third power cannot hit the x-axis more than 3 times. So like if you go here, I hit 1, and then 2, and then 3. It will not hit more than that. So this is more of a sketch than anything else. So I'm just gonna try to smoothly hit these points. And then again, since we know the end behavior will start up here and end down here, that's what it's gonna look like. Go ahead and do the next problem, please. Pause the video. We're not going to do the 2 underneath here, so don't worry about that. For now, we're just going to do this one to get the idea of how to do this. All right, so plugging in -2, that gives me -2 to the 4th minus -2 to the 3rd minus 4 times -2 squared plus 4. So that's going to be 16 plus 8 minus 16 plus 4, which is 12. For the next one, we have 1 minus -1 minus 4 times 1 plus 4, which is 1 plus 1 minus 4 plus 4, which is 2. For the next one, we have 0 minus 0 minus 0 plus 4, which is 4. For the number 1, you are going to have 1 minus 4 plus 4. So that's 0. And then for the last one, you will have 16 minus 8 minus 4 times 4 plus 4, which is 16 minus 8 minus 16 plus 4. I'm going through this fast because you should have already done this, so you can check to see if there's a number that you messed up on. You can pause the video and make those changes. So let's go ahead and plot these points. So for the first point, -2, 12, it's off the graph, obviously. So this is -2, 1, 2, 3, 4, 5. 6, 7, 8, 9, 10, 11, 12. So it's way up there. If you were actually going to graph that point, it's off the graph pretty far, but you can kind of tell which direction you're going to be pointing. The next one is at -1, 2. So that's here. The next point is at 0, 4, which is there. Then we have 1, 0, and then we have 2, 1, 2, 3, 4. Now, for this graph, this is an x to the 4th equation. So the degree is even, which means both, and its positive a value is +1, which means both ends will be pointing upward. And so, yeah, so it's going to look something like this. So it's pointing up to that, okay? And then we have to hit. And they both have to end pointing upward. So we don't really know if it turns right there. Oops, I missed that point up there. So it could go down further and then come up, but I do know it goes through there. So it's even, it's positive, which means both arrows are pointing in the same direction, and because it's positive, they're both pointing upward like a parabola does. So I'm pointing towards that, and I'm just gonna draw this. And again, we would need more information in order to figure out exactly where all these things hit, but that's generally the shape of it. All right, I think I'm going to go ahead and finish that there. If we have time in class, this is more of an in-class thing to sketch this. There's a lot going on here, so we will cover this in class if time permits, instead of doing that in this video.